Today we're going to start on section 4.4, which is exponential and logarithmic functions. So basically everything that we've been building up to, we've been teaching you this new algebra for how to do exponents and how to do logarithms, and now we're actually going to use them to solve for that ever so elusive x. So first of all, let's start off with some examples. Say we've got something like this. If I had 2 cubed equal 2 to the x, can you tell me what x is? You're like, yeah, x is 3, right? Yes, this is not a trick question. X is 3. If I said 3 squared equals 3 to the x, could you tell me what x was? Yes, x is 2. Very good. Okay, what if I said 16 is 2 to the x? Say, okay, this is a little bit more work, but I can do this. I can rewrite 16 as 2 to the 4th. So x must be 4, right? Yes, absolutely. So this is actually what we're going to be working on. This is one of the strategies we're going to use to solve these problems, which is basically if, what do I have? If b to the m equals b to the n, then m equals n. So this isn't some kind of arbitrary, strange, scary equation thingy. This is exactly what you just came up with. You said, oh, if 2 to the 3rd is 2 to the x, then x must be 3. If 3 to the 2 is 3 to the x, then x must be 2. So you instinctively know this. So that's what's kind of nice about it, is it's a fancy formula, but it's also a fancy formula you just made up by yourself. So this is really cool. Our basic strategy on this problem, or on these kinds of problems, would be you get the bases the same on each side. On each side of the equation. And then what you're going to do is you're going to set the exponents equal to each other. And it's really that straightforward. You're going to get the bases the same, you're going to set the exponents equal. If you can't get the bases the same, then we got a whole other kind of problem which we're going to talk about later. But for this initial part, it's going to be pretty obvious that you can write these as the same base. Maybe not inordinately obvious, but reasonably obvious. Obvious enough that if you see how it's done, you go, oh, yeah, I knew that. So let's give you an example right here. Say we had this. 2 to the 3x minus 8 equals 16. Problem that you probably couldn't have solved a while ago. So you might say, well, the first thing I'm going to do, I can kind of see looking at this problem, I've got a base 2 over here, and I know that 16 is a power of 2. So that's an indication that that's how I'm going to solve this problem. So I'm going to leave this the way it is, but I'm going to rewrite 16 as 2 to the 4th, right? 2 to the 4th? Yeah. I'm going to rewrite 16 as 2 to the 4th. Now that the bases are the same, I can set the exponents equal to each other. So I'll go ahead and add 8 to both sides, and then divide by 3, and get x equals 4. And that problem is actually done just about that quick. Okay, let's try another one. Try 5 to the 3x minus 6 equals 125. Okay, so you can say, okay, well, I've got the 5 here, and I'm willing to bet that there's a way I can write 5 to the something is 125. So 5 to the what is 125? 5 to the 3rd. 5 to the 3rd is 125. So let's set our exponents equal to each other. And we'll say, all right, 3x equals 9. Divide both sides by 3 and say x equals 3. Good? So this isn't so bad, right? But wait, we'll make it funner. All right, this is how you make this problem funner. Say we've got 27 to the x plus 3. Now you're already excited, I can tell. Equals 9 to the x plus 1. Okay? Now this is where it gets a little bit more dicey. So you're like, well, this isn't the same base. I mean, I can't say 9 to the what is 27. I don't know how to write that. Well, you can't write either of these in terms of each other, but you can write them in terms of something they have in common. So think about it. What do 27 and 9 have in common? They have a base of what in common? A base 3, right? So actually, I can write 27 as 3 to the third. So instead of having 27, I'll write 3 to the third to the x plus 3. And over here on 9, instead of writing 9, I'll write 3 squared. 3 squared to the x plus 1. Got it? Okay. So, do you remember how to do this? Remember, I've got x to the a to the b equals x to the ab. So I've got 3 to the x plus 3 equals 3 x plus 1. Okay. So then we'll go ahead and simplify that. Oops, here we go. 3x plus 9 and 3 2x plus 2. Now the base is the same, and I can equate the exponents. 2x plus 2, subtract my 2x, x plus 9 is 2, so that means that x equals -7. All right. So again, the basic ways that we make these problems complicated are by doing things like that, where you got to mess around with the bases, or we obscure it. So say we had something like this. 4 to the x minus 8 is 1 over 16. Look at this problem for a minute. So essentially, we want you to recognize that you can, of course, write 16 in terms of 4. But then we want to make sure that you remember, oh, okay, how do I get that thing out of the bottom? Is I'll stick a negative in front of it. So you should be getting kind of good at your exponent laws now, because we're using them all the time. And if you're having a really hard time with this section, or this chapter in general, it's probably, but quite possibly due to your exponent laws. We've got x equals 6 here. Don't you just love math chatter? All right, so let's say we've got, can you hear my toddler? He's upset about some kind of Thomas thing. All right, so now we've got this. We want to make sure that we can relate these two bases. So obviously the 7 is going to stick there. But what can you do with the 7? How do you rewrite the square root of 7 as 7 to the what? Square root of 7 is 7 to the 1/2. Okay, so I've got 3x minus 2 is equal to 1/2. Now I'm going to add 2 to both sides. 3x equals, all right, so I've got 1/2 plus 2, so that's 4 over 2. So 3x is 5 over 2. I'm going to divide this side by 3, which is the equivalent of, so dividing that by 3, I can multiply by 1/3. So what was I doing? Let's see, there we go. So x is 5/6. So honestly, this is about as crazy as these problems get, which, you know, is kind of a nice change, I think.